Okay, this is the other half of 13.5 and 13.6. So we're looking at a thing that's called the ambiguous case with triangles, and then we're also looking at two area formulas. So the ambiguous case, what that is when you have two different triangles that could be created with the given information. And this happens when you are given side-side angle. So that means you have two sides and an angle that is not in between them. So this is showing an example of that, of if you were given that angle C was 33 degrees, side B was 10, and side C was 6. That 6 could either, you could have, if I cover this up, you could have this triangle, or you could have the whole triangle with that middle piece covered up in there. Okay, so depending on how you look at it, it could be a obtuse triangle like that, or it could be an acute triangle on the inside here using the whole thing. So depending on what you're given, you could end up with two different triangles there. So we're going to look through how to determine that, and this gives us the steps there. And then these are our two area formulas that we're going to use on the back side. So first we're going to determine if we have two triangles or not, and then go from there. So the first thing I'm going to do is I'm going to sketch a picture of what I'm looking at. So I'm just drawing a general triangle and going from there. So if I have this, I'm going to say this is A, and that's 28 degrees. So then side A is opposite of that, so that's going to be 50. And then I'm going to make side B here 20, which makes that big B and that C. Angle C. So this is the information we have so far. It is side-side angle. That's what I have right now. So this could possibly have more than one triangle. We're going to test. So the next step is find the value of the unknown angle. So we're going to use our law of sines. So I'm going to say sine of 28 over 50 is equal to sine of B over 20. And now it's the cross multiply and solve. So 20 times sine of 28 equals 50 times sine of B. I'm going to divide both sides by 50. And then since I'm looking for an angle, I have to use the inverse. So what I'm going to say is inverse sine of all of this. And this will probably put parentheses around that too. So let's type that in. Make sure you are in degree mode because we're talking in degrees here. So I get about 10.8 degrees is what I'm looking at for my first angle B. Okay, so now let's look back up at my steps here. That was find the unknown value, so we did that. Then it says once you find the value of your angle, subtract it from 180 to find the possible second angle. So the possible second angle would be 180 minus the 10.8. Gives me 169.2. And then the next step in my list says add that new angle to the original angle that was given. If the sum is less than 180, then you have two valid answers, but if the sum is greater than 180, then that wouldn't create a triangle. So when I look back at this, my original angle was 28, so I'm going to add 28 onto this now, and that gives me 197.2. So since this degree measure was greater than 180, I'm going to use my therefore symbol here, getting a little bit fancy. If you don't remember, that means therefore. Therefore, we only have one triangle. Actually, I'm running out of space here. Trying to give us more space and not run into everything here. So this is one triangle. So we still need to solve it because the direction said solve the triangle and round to the nearest tenth. So we only have one triangle, and we did find one of our measurements. Angle B was 10.8. This angle didn't work because that gave us a sum greater than 197, so that can't be true. So to find angle C, I could easily find angle C. Angle C is just 180 minus the 28 minus the 10.8 we just found, which gives me 141.2 for angle C. And then the last piece I need to find is side C. So to find side C, you can either use law of sines or law of cosines. It's up to you. I'm going to use the law of sines here. So I'm going to say sine of 28 over 50 is equal to, cross multiply, divide both sides by the sine of 28. And if you type that in, you should get C is equal to 66.8 to the nearest tenth. So now we have solved everything on that triangle. Alright, let's look at part B. So I'm going to start the same way. I'm going to sketch a picture of what I have going on. So here's my triangle. I have 30 degrees here for A, 11 for side A, side B is 17. So here's my triangle that I'm starting with. So the next step is solve with what you have to find the possible side B here. So I'm going to say, or angle B, sine of 30 over 11 is sine of B over 17. Cross multiply. And solve. So I have to divide by 11. And then I'm going to use my inverse to find the angle. And if we type all that in, you should get 50.6 for our first possible angle B. So this, I am now going to check and see if I can get another triangle from this. So I'm going to subtract that from 180. And that gives me 129.4. And then I need to add the original angle onto that to make sure I can get another triangle, make sure that that would actually work. So I'm going to add 30 onto here. And that gives me 159.4. So since this is less than 180 degrees, that means I can have another triangle. So I could have two triangles here. Alright, so we've got a little bit of work to do. So this is my first angle, so I'm going to call that B1. This 129.4, that's going to be my second triangle. So that's actually going to be B2 here because this was my second possible angle. So I'm going to call that B2. Okay, so now I have two different things that are happening here. So I'm going to kind of draw my other triangle. So I could have this type of situation going on now. So this is 30, and then this would be angle B, which would be the 129, and then this is going to be my angle C here. So we have two different C's that we could have, so I can find both of those. So C1, I'm going to just do 180 minus my 30 minus the 50.6. And that gives me, where am I at? Sorry, I lost my spot. 99.4. So that's my first possible C angle. My second possible C angle, I'm going to use this now. So now I'm going to do 180 minus the 30 minus that. And that gives me 20.6. And now we have to find the two possible side C's. So law of sines or law of cosines, I tend to lean towards law of sines because I think it's a little bit simpler. So now I'm going to use my sine of 30 over 11. And then if I have to find side C, I need to use this. So I'm going to say sine of 99.4 over side C1. And we're going to cross multiply. And I'll end up dividing. So to save a little bit of time here, I'll just tell you what that is. This is going to give us 21.7 for your first possible side C. And then we're going to do that again for your second possible C angle. So our second C angle was 20.6, and cross multiply. And that gives you a C2 value of 7.7. Whew. All right. Those are the tough ones. The other side will be way quicker. So flip that over. Oops, that's blank paper. Here we go. Okay, finding the angle. So we have, or sorry, the area. We have couple new little formulas here that we can use to find the area of these based on given information. So the first one, if you look at the front side, we have these three, which are all formats of the same thing. So notice that if it's angle A, it's using sides B and C. If it's angle B, it's using sides A and C. If it's angle C, it's using sides A and B. So it's the two sides that are adjacent to the angle that are being used in this formula. So that is exactly what we have in this picture. So what I'm going to do is say that this is 1/2 BC times the sine of A, because these two are both adjacent to that angle, so I can use that. So my area is going to be equal to this little formula, and I'm just going to type that into the calculator, and to the nearest tenth the area would be 4.8 square meters. See, I told you those were quicker. And then example 3, we have a triangular flower bed with sides measuring 2, 6, and 7 yards. Find the area. So this we are going to use that Heron's formula that is on the other side. When you're given all three of the sides, we can use this. So S is half of the perimeter, and then we're just plugging in that formula. So you have the perimeter of the flower bed would be 2 plus 6 plus 7. So the perimeter is 15. S in this formula is half of the perimeter, so that would be 7.5. And then I am just going to plug it all in. So I have S times, and then it is S minus each of those side lengths. And that's all under one big square root. If you type that into the calculator, it gives you an area of 5.6 square yards. Whew. All right. So the last two, you're doing one of the triangle ones like on the front, and then number 2 is an area problem just like example 3. I think we need a joke after that. That was a long one. Let's see. Where do you take your sick boat? You take it to the dock. Okay, good luck on the last two, and have a great day.